Hawaiian island of Kauai, on the southern Mahaulepu coast, there's an intriguing natural sun-splashed sinkhole and cave system in the middle of the woods. You might expect to see Jurassic Park dinosaurs inside, but no, 5 million-year-old Kauai is far too young for dinosaurs. But what this cave and sinkhole system has revealed is quite exciting. Caves, holes in the earth, and hidden places are naturally fascinating and seem to beg us to explore and study them. There are many who are interested in this sinkhole system found near the south shore of Kauai. Scientists are revealing a historical record like only a scant few found on Earth. Excavations deep into a 10,000-year-old pond have revealed fossil evidence of at least 45 species of birds and layers of countless plants and other animals. A record of uninterrupted history of pre-human Kauai that extends up into present time tells us of natural disasters, changes in plants and animals, and how the many arrivals of humans have impacted this isolated island locale.
Okay, in order to understand the origin of the sinkhole we see here, we first need to figure out how the rocks formed in which the sinkholes developed. The rocks you see behind me are limestone, and there's two critical observations that geologists would make to give them a clue as to how this limestone formed. The first are the large inclined surfaces that you see in the back of the sinkhole, which geologists call cross-bedding. And the second is that when we look at the rock close up with a magnifying glass, such as this, we would see that it's composed of tiny sand grains that are cemented together. So here you see an example of the lime sand that would be coming off of the beach. With time, this lime sand becomes cemented to form a limestone, which would look something like this. So after the sheet of wind-blown sand, or the piled up sand dunes, formed into a layer of limestone by cementation, we next need to figure out how to dissolve part of it away to create this sinkhole. That was done by a spring which is upslope from this area, which eventually created an underground river flowing under the limestone and producing underground caverns. As the caverns became larger and larger through dissolution of the limestone, the top eventually fell in, therefore creating what we call a sinkhole.
Since 1992, after Hurricane Iniki, paleoecologists Lyda and David Burney, with hordes of volunteers, have persistently cleared and cared for the sinkhole. They are restoring the native vegetation around this scientifically significant and Hawaiian sacred site.
This would have been a shallow lake even up until the memory of people still living today. Lakes create a wonderful environment for preservation. I mean, what it means is that anything that fell into this lake would have settled to the bottom and then preserved in the mud in the oxygen-free conditions of the lake. And another very important thing that was going on here is pH. Bones are generally preserved in nice alkaline conditions. So if you find a fossil site and it's got good bone preservation, you generally don't have good pollen or seed or wood and artifact preservation, because pollen, seeds, or wood likes acid conditions. This site is unique in that it has a very neutral pH. The alkaline walls from the limestone is buffering that acidic conditions that the volcanoes create. So we have preservation of everything, and I just can't stress how unique that is in any site anywhere in the world. So we have everything we need here. We have the neutral pH, we have the cave environment, and we have the lake environment.
Lyda and David Burney, with teams of archaeologists, naturalists, geologists, and many other scientists, have uncovered a 10,000-year-old fossil record that is the most diverse in all of the Hawaiian Islands.
From looking at our fossil seeds, this is the Pichardia that was growing here. There are only 2 of this particular Pichardia left growing in the wild, and they're on the island of Ni'ihau. We have about 60 that are growing on site right now. We put them in the ground here and they do incredibly well. We have collected many pounds of seeds off of them at this point, and then germinated those seeds and are planting more and more of those both here at this site and in other restoration sites. Another plant that's well represented by our fossil pollen is the native Erythrina, the willy willy. A few years ago, this was really hammered hard by the Erythrina gall wasp that was introduced here, quite accidentally. And the willy willies were all dying, and they introduced a predator to this gall wasp. They were very careful to test this quite extensively and make sure that the predator wasn't going to become an invasive insect that was introduced, and that it would only eat the gall wasp on the Erythrina. We were one of the study release sites. It's done quite well here.
In their nearby Field of Dreams, or native garden, David and Lyda are bringing plants found in the pollen evidence from these ancient records back to life as they propagate these rare plants.
Through the generosity of Growth Farm Incorporated, we actually have 17 acres here that we are trying to restore to its native habitat. Of course, this is something that can't be done by 1 or 2 or even a handful of people. It's been an effort of an incredible number of people, volunteers, school groups. We often have school groups of as many as 250 kids. No matter what your expertise is, we have a job for you. So if you like to pull weeds, we've got a job for you. If you like to keep records, if you like to do publicity, we have a job for you. No matter what it is that you like to do, we will find something for you to do. It's very important for us to understand the past and to understand the processes that created extinctions in the past. Because if we can understand that, perhaps we can prevent these things occurring in the future. We can certainly learn from our mistakes if we can understand our mistakes.